Instructions here, guys, for your simple harmonic motion assignment. This is what you're working on today, so you should be able to get like pretty much all of it done, all right, and not have too much homework. Okay, so don't overthink any questions. Okay, it's going to deal with stuff as simple as the period of a pendulum, period of a mass on a spring. There's going to be some Hooke's law stuff, and there's going to be some conservation of energy for a mass on the spring. Okay, that kind of stuff. That's what's on the first half of the unit, simple harmonic motion. All right, so for question number 1, you're given the period of a simple pendulum, okay, and asked to find its length. We would, of course, assume that that pendulum is located where? Earth. Okay, so that's your other given on that question. Okay, question number 2 is about a grandfather clock that is going to be moved from one location to another where G is different, and thus the length of the pendulum must be adjusted for that change in gravitational acceleration. Right, so you'll probably have to do a couple of calculations there, maybe an intermediate one, okay, before doing your final calculation to calculate the length in the new location. Okay. For question number 3, another pendulum question, you're told the length, okay, and you're being, and it says that it executes 100 complete cycles in 280 seconds. You are going to have to use those two numbers to get something else for the pendulum formula. Okay, make sure you use them in the right fashion. Okay, number 4, okay, is about a wrecking ball and a small pendulum. All right, so a bright student wants to estimate the length of the cable on the wrecking ball. Okay, so what he does is he takes a small pendulum and he sees that it makes 5 complete oscillations in the time it takes the large pendulum to make 1 complete oscillation. It is really important about this 5-to-1 thing. Okay. All right, so the little pendulum makes 5 cycles. The big one makes 1 cycle. Okay, we're looking for the length of the cable on the wrecking ball. Okay, from that information. Obviously, this also occurs where? Earth. Yeah, where G is 9.81. All right, and then another pendulum question. So like the first 5 questions are pendulum questions. Okay, so we have the length of that pendulum. We want you to find its period, and then how long the pendulum would have to be to double its period, and then tell me why that number is not just double the length. Okay, so I'd be looking for a little bit of an explanation here that talks about the nature of the relationship and the thing that's in the formula. Okay. For number 6, another pendulum question, it's find the length of a pendulum oscillating on the moon that would have the same period as a 1-meter pendulum on Earth. So you probably have to find the period of a 1-meter pendulum and then figure out, okay, how long it would have to be on the moon. All right, number 7 is the one that gives people trouble. Okay, and it's because they don't pay attention to the details in this question. So this is where mass on a spring questions start. Okay, so in the first situation, mass 1 and only mass 1 is hanging on the spring. So this is situation 1. Mass 1 is on the spring, okay? And it is set into simple harmonic motion. Its frequency, not its period, its frequency is 10 hertz, okay? When another object of mass 2 is hung on the spring along with mass 1, so that means the second situation, both masses are on the spring in the second situation. Okay, not just mass 2, both of them are on the spring. The frequency of the motion is 5 hertz. Find the ratio between mass 1 and mass 2. That is, how many times bigger is one than the other. All right, now here's the trick to this question. You are never told the spring constant in this question. Is that something you need when calculating the period of a mass on the spring? Okay. Is it the same spring in both situations? It is. It says that in the question. First there's mass 1, and then mass 1 and mass 2 are hung from the spring. The spring. It's the same spring. Okay? So, if it's the same spring, is K the same? Since you're not given K, can you just pick one? Here's why you can just pick one. You're never asked to find the masses. You're asked to find the ratio of the masses. So you're actually only finding numbers that represent the masses, not the actual masses. Okay? Finding the ratio doesn't require you to actually find the real mass, so you don't need to know the real K. You can pick whatever K you want. Okay? I did not see very many people write that big, giant, juicy hint down, so you're probably going to have to listen to this later, because you won't be able to do that question without that big, juicy hint. Okay? All right, question number 8. Okay, spring with a constant of 1,526 newtons per meter is oscillating with a frequency of 3 hertz. What mass is suspended from it? Just a mass on a spring question. Okay, number 9, another just mass, simple mass on a spring question. Okay, number 10, also just a simple mass on a spring question. Okay, but something to watch out for. And in fact, this comes up several times on this worksheet. If something oscillates 5 times, did I measure that or count that? I counted it. Do counted numbers count for significant digits? They do not. Anywhere where a number of oscillations is counted, keep in mind that that counted number does not affect your significant figures. Okay. All right, for number 11, okay, another just, this one here, okay, you're moving into conservation of energy, okay, or just energy, okay, and number 12 and number 13 are also not even conservation of energy, they're just energy questions, okay, so they're just like simple energy questions. Don't overthink them. They're only out of 3 marks. Okay? They're not conservation of energy questions. They're just energy questions. Okay? All right. Questions from you guys? All right. Don't forget that counted number thing that comes up in like 4 different questions.
When does this due?
I'm thinking I'd like to have it for Thursday so I can go over it on Friday with you, and then you won't have. Well, you'll have the pendulum lab over Christmas, but I think you'll probably get that done in class tomorrow too. So I'm thinking Thursday for this, the pendulum lab I'm making due January 9th. Okay? But if you work on this pretty hard, you'll probably be done 4 classes over. Okay? All right, get started.